In this video, we'll be talking about the unique pointer, which is a smart pointer. It is a smarter way to use new. In our previous video, we used new to create a new object and delete to clean it up. And that works, but it's easy to forget to call delete. And forgetting to call delete causes memory leaks. So in this video, we are going to demonstrate the use of smart pointers to replace any of our raw pointers that we created in the previous videos. But let's have a look a little bit about what smart pointers or what is this unique pointer. The unique pointer is basically a smart pointer from the C++ standard library. It owns the object you give it, and when the unique pointer goes out of scope, it automatically calls delete for you, so there is no need to remember delete. So let's start with the steps. The first thing we want to do is to include memory. We're going to need that to access the unique pointer. All right, now the next step is to replace our raw pointer that we created in main, okay, with unique pointer. So we'll basically just use unique pointer. Now, usually this would here, you'd specify the type. In this case, we are going to be creating the object of type myResource, which is a class that we created earlier in previous videos. We will get rid of the pointer. Now we are just using unique pointers. And let's call this something a bit more relevant. So I'll call this smart PTR, smart pointer. And we'll make unique of type myResource heap. So basically what this means is we created a unique pointer that manages a myResource object constructed with heap, okay, constructed with heap, and stores it in a variable named smart pointer. So basically unique pointer here is like a wrapper around the raw pointer. All right, in step 3, there is no need to call delete. So when smart pointer goes out of scope, it automatically calls delete. So we can get rid of that line. All right, so in step 4, we also want to change the raw pointer that we created here to a smart pointer for array. So again, we'll be using unique pointer of type integer this time. And oh, it's an array. And we can keep the name as data. So this is a smart pointer for array. So basically unique pointer here, this line, knows it's managing an array. So it uses delete automatically. All right, now let's have a look at the step 5. We want to replace raw pointer with smart pointer. So here we have sort of created the instance variable, but now we want to create the object, basically. So we will use make unique instead of new, make unique of type integer. It's an array of integers and 5 elements for an array of 5 integers. And that line is just for logging purposes. But moving into step 6, there is no need to call delete anymore because unique pointer does it for us. Now at this point, it feels like the destructor is not really very useful. But what the work that we've done is just less manual memory management. Means fewer bugs basically. The benefit of doing this, of using smart pointers, is that if someone later modifies your class and forgets to call delete array, it's still safe. Because if we're looking back here at the destructor, because we've switched to smart pointers, in this case, like the unique pointer, So that takes care of deleting the array, and we no longer need the destructor for the purpose of freeing the memory like we had. So the smart pointer does it for us. You would still need destructors if you still like say managing other types of resources, or you just want it for logging in, sort of just for logs or whatever. You want to display something to the user, or you've got to log when cleanup happens. So you want to keep the destructor. In this case, I feel like it's not really useful, but let's just keep it just to show that the program still works. We've built and run it. Still works exactly like it was working when we had used the raw pointers. So let's take some key takeaways from this video. The unique pointer is a smart pointer that wraps a raw pointer and manages its lifetime automatically. Only one unique pointer can own a given object. It can't be copied, only moved. Now this prevents accidental sharing and double deletes. I would probably make another video on this point. It's a bit more details need to be explained. But use make unique instead of new. So you notice that every time we had a new, we used make unique. It's because this is safer, cleaner, and helps prevent memory leaks. So this line is the one that manages the delete. This part replaces new. So this part replaces delete. This part replaces new. Finally, no new. Okay, so that repeats what I said. Make unique takes care of allocation. No delete. Unique pointer handles the cleanup in its own destructors. So no new, no delete means no memory leaks, and that's the power of smart pointers. I hope this video was helpful, and I'll see you in the next one. Thank you for watching.